So question number 1 at the root is asking us to approximate a y value on a function that we do not have an equation for. The good news is they gave us a clue that they want us to use the tangent line. I don't know if you remember in class when we talked about, like we played Would You Rather at the beginning of class, and we said, would you rather plug a decimal x value into a not right function or into a linear function? We said it's always nicer to plug into a linear function, but we have to remember it will be an approximation. So we're going to write the equation of the tangent line. Again, we have a point, and we have the slope at that point. So I have y minus 4 equals 2 times x plus 1. Here's my tangent line. I'm going to even move that 4 to the other side. This is the tangent line. Instead of plugging this x into g, we're going to plug this x into the line. And so our approximated y value is 2 times negative 0.2 plus 4, or 3.6. Good. Question number 2 says, find the average rate of change, right? So there's a key phrase right there, average rate of change. We have a formula for this. It is finding the slope between 2 points. It's my f of b minus f of a all over b minus a. Now, they didn't call the function f or g, they called it y, so I kind of left it as f. But here's my a and my b. So I'm going to do f of pi over 2 minus f of 0. Gosh, sorry. Couldn't see any of that. All over pi over 2 minus 0. So let's say if I go plug a pi over 2 in here, I get the cosine of pi, which is negative 1. When I plug in the 0, the cosine of 0 is positive 1. And so I get negative 2 over pi over 2, which is negative 4 over pi. Take a look at question 3. I better back this up before I keep running off the page every time.
Attention staff.
So question number 3, we're going to need a calculator. We're going to make sure that calculator is in radians. And unlike 2, when it said find the average rate of change, remember rate of change means slope, this one is asking us to find the average value. Well, we have a formula for that, right? If you want to find the average, we said you're going to add up all of the values on that function from 1 to 3, and then we're going to divide by 3 minus 1, right? So it's still an average question, so we're still dividing by the length of the interval, just happen to throw it out in front. So I'm just going to grab my calculator, I'll leave it right here, I'm in radians, and so I'm going to do 1/2 times the integral from 1 to 3, and I lost my function x cubed. Gosh, it's so blurry. I'm so sorry.
Shakayla Dickerson, Shakayla Dickerson. This is your 3-minute warning. Your transportation will leave in 3 minutes.
Sorry about that. And then we have x cubed times the cosine of x squared plus x. I believe I keep moving this, I know. Sorry. Yeah. Oh, of course, you know. Oh, forgot my x at the end. Sorry. All right. And so we cross our fingers, we see this on the list, negative 0.945. Woo! Okay, so far we've reviewed average rate of change and average value, right? Very different in terms of how we calculate those. All right, question number 4. Again, the root of the question is saying write an equation of a tangent line to the graph of g when x equals 2. So if I'm talking about the function g, I need a point, which they gave me the x coordinate, and I need the slope. All right. Well, let's go backwards. I didn't read the whole question, but they said g is the inverse of f. So this is the inverse of the original function f. Well, what we remember about functions and their inverses is that they have, we switch the points, right? So if this is an x coordinate of 2, the y coordinate will be 2. and we flip the slopes over, right? At corresponding points, the slopes are reciprocals. So I'm going to start with that, is that I do know the y coordinate is 2 on f, and so I'm going to look at the y values on f. That happens when x equals 3, which means I have the point 2, 3 on my inverse, which, to be honest, I think helps us get rid of 2 choices here. Now, we still need the slope at this point, but we can find the slope at this point. When x equals 3, the slope is 5, meaning on my inverse, the slope is 1 over 5, and that gets me my answer, C. So a big takeaway here, we flip the point and we flip the slope. All right, question number 5, a piece of rubber tubing. I'm not going to read this, you've already read it. We have a cylinder. The inner radius is 2, the height is 20 at one instance. The inner radius, r, is decreasing, so dr dt is negative 0.1. The height is increasing at 3 millimeters per second, so that's positive, right? Which of the following statements about the volume of the tube is true? So they're talking about the rate of change of the volume. So we have the formula for the volume of the cylinder, which is a product of variables, and we want to take the derivative with respect to time, right? And I know that because I saw the units, like millimeters per second, right? That means time is in the denominator. So I'm going to use the product rule. Actually, I'm going to leave the pi out in front, like as a constant multiple. So dv dt equals, there's my pi. I have the first, which is r squared, times the derivative of the second, which is dh dt, plus the second, which is h, times the derivative of r squared, which is 2r, chain rule says, times dr dt. I'm going to start filling everything in. So I've got that pi out in front. The radius is 2, so I have a 4 here. dh dt is positive 3. Let's see, h is 20, r is 2. So let's see, what did I just say? I guess I could just write it out. So I have 20 times 2 times 2 times negative 0.1. So let's see, we have 8, right? 80 divided by 10, 1/10. So 12 minus 8, 4, and so we get a 4 pi. And it's a positive 4 pi. So I was just kind of reading my answers. So because we got a positive 4 pi, the volume is increasing at 4 pi cubic millimeters per second.